Today we're going to talk about OpenStack, the real basics of OpenStack. This is part of a series of videos that will help you understand what is OpenStack, what are some of the advancements and new technologies that are coming with OpenStack that are relevant to Cisco, and also why is Cisco involved with OpenStack? Because traditionally we haven't done open source. This is an open source environment, community. What is Cisco doing in this space? Why is it relevant to us? What does it mean from a competitive perspective, and what does it mean from potentially an advantageous differentiation perspective? So we're going to get started with what are the basics of OpenStack. Now, before we even get started with that, it's always good to make a comparison between something that most people understand and something new. So we're going to get started with kind of what does today's infrastructure as a service look like from a cloud perspective, and I'm going to use VMware plus Cisco plus our storage partners type of stack because a lot of people are familiar with that. So in today's environment, the stack looks something like this. You've got storage, which is built to be highly available using RAID and a number of other high availability technologies. You've got the network infrastructure, which is built to be highly available using HSRP, VRRP, VSS, multi-link, lots of high availability capabilities within the infrastructure, both at the network and the storage layer. You've got something that's going to manage your virtual machines, so something like vCenter. You've got something that's built to manage clouds, or the concept of like tenants or customers or multiple groups of VMs that are for a specific business or a specific function. And then up top above that, you typically have vApps, or a way of building applications that could either be new applications, web applications, or in a lot of cases are traditional legacy applications, whether those are SAP, Oracle, Microsoft, three-tier business applications, whatever. Now, the key to this, and this will be where we'll start in our contrast point, is down in here, in the past, we've always built extremely highly available infrastructure, whether that's at the network layer or the storage layer, right? This is pretty traditional. We're going to try and manage the resources that we have. And then the applications that we have in most cases weren't necessarily built to be completely elastic. They were built to just run more efficiently. So what you have is less knowledge of the infrastructure, expectation the infrastructure is always going to be there and always going to be highly available, always going to provide quality of service. And the applications just sort of expect it to be there, right? They're not building specific logic to do things differently. Now, if we contrast that with OpenStack, there's a couple of different things here. First, today's clouds traditionally, whether they're from VMware or they're from Microsoft or some of the other traditional vendors, tend to be more closed. Obviously, there's some differences with that, with maybe what Citrix does or some others, but they tended to be more proprietary or closed in terms of being able to get access to the source software. Doesn't mean APIs weren't available. Now, let's compare that to OpenStack. OpenStack is an open source project. You can read about the history of it, so we won't go into that here. But OpenStack has a couple very, very different properties. First and foremost is it's completely open source and it's completely community based. So there's an opportunity for us to collaborate with other vendors in the industry, with our partners, with other technology companies, completely open source. The second thing is, instead of being built on applications that may have been legacy applications, right? It is designed for the new types of applications, web applications, big data applications, cloud applications, applications that expect to scale dynamically, scale up, scale down, and the applications are specifically built to have that sort of knowledge, that the application is going to understand how to scale the infrastructure, how to scale it up and how to scale it down, how to deal with an infrastructure that may not be highly available, that may fail from time to time, and so you'll hear people talk about design to fail. So the applications are going to be cloud or web applications. We're not talking about legacy applications here. Within OpenStack, there really today are sort of three main components. The first is something called Glance. Glance is the code name or the project name for the image repository, the thing that's going to keep track of your ISOs and all your builds and all the things you need to create and pull together an application. The second piece is called Nova. Nova really focuses on the compute layer, right? How do I get commodity or any x86 platform to be able to boot, to load images, and to do compute functions, okay? And the third current thing today is called Swift. Swift is the project name for the storage. Now, let me talk about some differences here. First, again, applications, cloud, web-based, expectations to scale, intelligent applications, not legacy applications. Second, the compute portion, we're looking at pools and clusters of x86 resources. Could be super small, could be super large, but again, clusters and pools of x86 resources. The storage piece, instead of being file-based or block-based like we have in sort of today's infrastructure as a service, is going to be object-based. So again, it's instead of being based on file systems or block-based systems, iSCSI, EFC, things like that, it's based on object-based. So it's HTTP-based, puts and gets, a different type of the ability to do very, very scale-out object-based storage. Now, a couple other things to keep in mind. There's not necessarily today in the Cactus release, which is the third release, kind of a strict definition of what the network looks like. And we're going to talk about that in future versions. But in essence, the expectation of OpenStack in these applications is the infrastructure is going to fail from time to time. It's not built for complete high availability, at least of any individual component. So the expectation is the application will be able to deal with an individual storage controller or storage device failing, disks failing, the network failing to certain levels, or compute failing. Okay, so very, very different. Instead of this infrastructure being incredibly intelligent and super highly available at every component level, the expectation is that this will fail from time to time, right? Maybe you're using more commodity-based infrastructure for cloud scale things. The other thing is expectation that the applications are going to be very, very intelligent, right? So again, sort of flipping the model on its head to get to these very high scale, very lower cost to deploy or lower cost to fail applications. And the ability to do this in a way that can be controlled, can be scaled up and scaled down on the needs of the application. So you wanted to use that as a starting point for our OpenStack discussions, sort of traditional infrastructure as a service clouds, intelligent infrastructure, lots of availability built into the infrastructure, some mix of web and legacy applications. In this case, all new applications, big data web applications, lots of intelligence built into the application layer, some definition of compute and storage today, as well as where the image repositories are, but less sort of highly availability-ness and less maybe intelligence per se in the infrastructure because we expect the applications to do more in that space. So I'm going to wrap this up. Hopefully that gives you the basics of OpenStack, and we're going to dive more into this layer here of network and what Cisco's role can play in that space, what Cisco might be doing in this space, and ultimately why we're involved with OpenStack. Thanks, and the links that we'll put this to will point you to much more definitions, questions, Q&A, and information that can help you with OpenStack.